All right, last one here, problem 19. Got a probability density function, and we want to find the k value. So we integrate from the whole region and set it equal to 1, because probability distribution functions always add up to 1. So this just becomes k sine x from 0 to pi over 2. So that's k times, sine of pi over 2 is 1, and sine of 0 is 0. And so we just get k times 1 equals 1. Therefore, k equals 1. 4 marks for that. That's some easy IB points right there, everybody. 4 marks just for doing that. Part B, 12 marks, obviously going to be more involved. Variance of X, 2 different ways you can get it. It's usually easier to do it with the e of x squared minus mu squared formula. So let's try that. So first I'll get mu. And remember, mu is just interchangeable with e of x, which is just interchangeable with integral of x times the probability density function. And k is equal to 1, so I just need to do this. And so I like to think of this just as, this is just fun with integration by parts. So u equals x, dv equals cosine x dx. So v equals sine of x, du equals dx. u v minus integral of v du. So that pops out to be x sine x minus negative cosine x. Just make that into a big plus. Evaluate that from 0 to pi over 2. So pi over 2 gives us pi over 2 times 1 plus 0. 0 gives us 0 times 0 plus 1. So I guess we get pi over 2 minus 1. That's our mu value. Then expectation of x squared. This one's going to suck a little bit more because it's going to take us 2 steps to get through it. 2 integration by parts. So u equals x squared. dv is cosine x dx. du is 2x dx. v is sine of x. Write out the first part. X squared sine x minus the integral of v du. Do it one more time. U is 2x dx. U is just 2x. dv is sine x dx. du is 2 dx. v is negative cosine x. So I'm just going to drop that first piece down. X squared sine x minus another uv, negative 2x cosine x, minus integral of v du. All right, I'm going to deal with all of these negatives here. So this double negative makes a plus. Integral of cosine is sine. So I've got x squared sine x, distribute the negative, plus 2x sine x, distribute the negative, minus 2 sine x. That should work out. And, allegedly, if you take the derivative of all that, you'll get back up to x squared cosine x. I kind of see how it all will work out. And that's going to go from 0 up to pi over 2. So when you plug in pi over 2, you're going to get pi squared over 4 times 1 plus pi times 1 minus 2. And when you plug in 0, you'll just get 0 for all of that. Does that work? Pi squared over 4, yep. 2 pi times 2, yep, okay. So that simplifies out to be whatever. Okay, so then what we're going to do is take our two answers and put them together. This is getting a little bit messy, but that's what happens with the 12-mark problem. So we have e of x squared and we have mu right here. So we're going to say this answer here minus this answer squared. And it should pop out to be pi minus 3. Otherwise, I have wasted a lot of time in this video. So let's erase a little bit of this stuff up top. And hope and pray that I didn't make a fraction mistake several minutes ago. Okay. So we've got pi squared over 4 plus pi minus 2 minus pi over 2 minus 1 squared. Pi squared over 4 plus pi minus 2 minus pi squared over 4. Let's see. What does this come out to be? We have a negative pi over 2 and another negative pi over 2. So that makes negative pi plus 1. We're subtracting all of that. And this cancels this. Plus pi. That gives me 2 pi minus 3. Okay, what did I do wrong? Ah, I found it. I wonder if you can find what I did wrong. If you can't find it, it's right here. Did anybody see what I did? I just switched a cosine to a sine. If I change this to cosine x, then when I substitute in pi over 2, this part actually equals 0. And then that means I can follow that through and I can get rid of my pi here, get rid of my pi here, and I'm back down to 1 pi minus 3, which is what I was supposed to show. So the nice thing about one of these hence problems is you kind of have a double check at the end. There's a lot of action going on. You get to the end, you say, oh crap, I have an extra pi. And so I was looking at the only places where that extra pi could have come from were from the middle term right here of my e of x squared, or maybe something was wrong right there. I felt pretty good about my mu calculation earlier, so I started scanning backwards through my e of x squared calculation, saw a pi right there, checked that middle term. It didn't match with the previous step. I just copied it down wrong. So there you go. Please comment or ask questions, and I'm happy to make more videos, but I hope that was helpful.